perspective was a broadcast. But now when that information comes back, guess what it's going to be? The destination is going to be specific. So a broadcast goes out does not have to be a broadcast when it comes back. It's a layer 2 unicast message now. Once this is done, PC1 can now build this ARP table when he gets this information back, and now he can send his ping. There it is. It's a ping request. What is a ping request? A ping request is just saying, please reply back to me. If we look at this information, let's find out really what's in a ping message. It specifically says this is an echo ping request. It is requesting for you to send something back to me. And just send the data that I'm sending to you, send it back to me. That's what the echo is. So let's look at this. There's our data. All right, that's really what we're sending over there. And look at our data down here. A, B, C, D, E, F, G. It's just the alphabet. N, O, P, Q, R, S, T, U, V, W, and then it starts with A, B, C again. And this nice little thing here that says, hi. How you doing? And that's what's in a ping when we're sending a ping from PC1 and from Windows. So now we're going to get the message, a reply back from a ping. Let's see what it says. Same thing. Because we asked them, look, send back an echo reply, please. A request. I'm requesting you to reply back to me. So the original one was a request, and the information that comes back into PC is the reply he was expecting to see. And that's it. We got some other ARP stuff here, and starting to get into some Microsoft stuff, so we don't really care about that. But this is how the information begins. So whenever you're configuring something, if the first couple of pings fail, what do you think is happening? We're probably trying to resolve ARP. We probably sent out an ARP message. And if we sent out an ARP message, we have to wait for it to come back. And during that time, as we're waiting for it to come back, we've already failed that ping. Now I'm going to go ahead and fix this diagram here. Now, let's go back and take a look a little bit deeper here with this ping. As I send out my ping requests, here's my data. We looked at the data that's going out. Guys, you can get really granular with this as far as going to each one of these fields. I'm just using this as a means of showing you how this is done. But this is a very awesome tool to use to be able to really see the data that's coming out of your network interfaces and going through your network. So this is really our data here, and we encapsulated this data with an ICMP message. Now, what does that mean? An ICMP message. Notice that when I'm looking at the ICMP message, I can't see the data. I have to open up this in order to see the data. I had no idea data was there until I opened it up. And there's the data. Let me open this up and see really what the data is. Okay? This is the concept of encapsulation. Inside the ICMP message, there's data that's been encapsulated. On top of this is the layer 3 information. Here's our source IP and our destination IP. So whenever a router gets this information, he's not going to see the ICMP packet. He's just going to see what? This. He has to open this up and remove this in order to see that it is an ICMP packet or ICMP message. So this internet protocol, which is version 4, this is just IP information. You can actually see all the information that's in what we discussed, the IP header. This is the IP header. You got your version, you got your header, and down here you have your you got your flags, and the most important aspect of it is our source and destination. Here's our source IP, 192.168.1.1. Remember, we're still sitting on PC 1, and our destination is 192.168.1.2. This information is encapsulated with layer 2 information. And look at our source information and our destination information coming from PC 1 to PC 2. Isn't it nice to have the MAC addresses set that way so you know which PCs they are? And this is the real reason why looking at Wireshark to make you understand this concept of encapsulation. And we take all this information and we bundle it into a frame and send it on its way. So we got a pretty decent look at what this looks like, this whole concept of basic communication. We have our data, which in this concept is really just an ICMP message. In that message, there is some data, but really here the data is the ICMP message. And we encapsulate that with our layer 3 information, which the routers will use to make forwarding decisions. And on top of that, we encapsulate with layer 2 information, which is what the switches use to move data. So when that information comes into this switch, he's going to look at the layer 2 information. The first thing he's going to notice, let's take a look at this layer 2 information. Oh, the source MAC address. That's 1111. Do I have that in my MAC address table? Nope. Let me go ahead and add it. And I'm going to add it onto this interface, which will be FA01. And then 02 will be PC2. Then it's going to say, well, I need to send it out to 2222. Do I have that in my MAC address table? If not, what am I going to do? Send out a broadcast. This is the switch now. If I do have it in my MAC address table, oh, I see that now. Which port is it attached to? It's attached to port FA02. Let me just switch that data that came into here right out this port. This is why this information is very crucial for basic communication for you to understand. Very important. So, we're going to find out now what happens when the PC communicates with someone on another network. So originally we were saying that when I need to communicate with this device here, I'm going to have a source IP, and this is from PC 1's perspective. I'm going to have a source IP of 192.168.1.1. I'm going to have a destination IP of 192.168.200.8. I'm going to have a source MAC of 11 and a destination MAC of what? Now, the question was, because a lot of people ask me this, well, wait a minute. The PC1 knows that he's communicating with someone outside of his network. So if he knows he's communicating with someone outside of his network, he needs to send it to his default gateway. So if he needs to send it to his default gateway, that means my source IP needs to equal 192.168.1.1, and my destination IP needs to equal 192.168.1.10, because I'm sending it to my default gateway. Ah, well, that's interesting. That was the original question. That's how this lab started all in the first place, right? A lot of people think this way, and I want you to understand the logic. That whatever's in my destination field, on my IP header, and I'm going to be using an IP header to forward data, whatever is in that field means that that's the destination that I need to send the traffic to, which means it goes no farther. So if I put this destination IP address as my default gateway, I'm saying that my default gateway, which is router 1, is the destination of this packet. It doesn't need to go any farther. It needs to go to router 1. But that's not where the packet needs to go to, is it? The packet needs to come over to here. So when router 1 gets it, he knows, if it's this information, he knows that that's from him, and he's going to open it up. He's not going to forward it on if the traffic is meant for him. There's no point. Routers make their decisions, their forwarding decisions, based on the layer 3 information. Well, if that's the case, then my destination, in order for it to get here, must be 200.8. Otherwise, if I change that destination over to here, it'll never go past this IP address. And that's exactly right. Then how do I send it to my default gateway? How's that even possible? Well, let's take a look at it. First thing I want to take a look at is my MAC addresses here. Let's see, show IP interface brief. Because we don't have the MAC addresses written up here, so we want to see what they are. Show run, or show interface, FA00. So for FA00, look what I put the MAC address. Well, that was pretty nice of me, wasn't it? It's just all zeros, and the last digits is 168, meaning that we're on the 168 side. So let's take a look at FA01. Well, that's nice. We're on the 200 side. So obviously, if I pull a MAC address of the 200, I'm on this side. If I pull a MAC address of the 100, I'm on this side. So let's go take a look at PC1. And let's see how PC1 handles this traffic. We do want this running in the background. We're going to hide this ink here. And we want to change our options. We want to go to 200.200.8. This is the host we want to pay attention to. Let's go ahead and start our traffic. I'm going to still do a in count of 1. I want to say 200.200.8. Notice we got nothing. Let's try it again. And this is just a count of 1. Nothing. First of all, let's make sure I got my options here correct. Yep. So let's take the in out. Let's try to see if we can get any traffic coming back. So now I can troubleshoot and figure out what's going on. First thing I want to pay attention to, can I hit my default gateway? What is my default gateway? Ping 192.168.1.1. Nope, 1.10. And I can't even hit my default gateway. So let's find out why. This might be a VM issue. Okay, I found the issue. It's not going to accept PC1 as far as the router is concerned. The router is not going to accept this as a ARP entry because of the fact that I set it all to ones. And this has to deal with multicast. So I'm not going to get into that explanation. The bottom line is PC 1 and 2 will be able to communicate with those MAC addresses, but the router will not bring that 1.1.1.1 in the ARP table. All right, so let's just go on to PC 2. And let's see how this traffic works. It does say PC3, but that's fine. Let's bring up Wireshark. I just forgot to change the name of the account. And let's go to interface. Let's go to options. And we want to look at the 10.200.200 host. 10.200.200.8. That's the host we want to focus on. Let's move you over. And we're going to ping 192.200.200.8 and 1. Now, let's see the first bit of data that goes out. We got our ARP and we got our reply. Now, let's really take a look. Let's bring our ink back here on what we had. Let's move this over. And let's look at what information we really sent. Now, remember, PC2 we're going from a source of 192. Let me change these preferences here. All right, notice our first thing here. Notice our first communication is 192.168.1.2. That's where we're going from. And we're going to 192.200.200.8. So what does that mean? We're going to an IP address that's on a different network. So now, let's take a look at how that traffic's getting there. Here is my data, my ICMP message. Let's take a look at this. Well, wouldn't this make sense that 192.200.200.8 will be the destination? Because remember what I said, the destination is where the traffic ends. And that's it. If that's where it ends, that's where it ends. So because of this, how do we get it to our default gateway then? How? Well, let's take a look at the layer 2 information. Very interesting. Remember that 168 address? Isn't that this one right here? There it is, 168. Oh, so we're moving the traffic to the default gateway by the MAC address. Very interesting.